In modern cloud-native environments, visibility across sprawling, heterogeneous infrastructure remains a primary operational challenge. To address this gap, the Management Pack Builder in VMware Cloud Foundation 9.1 has been significantly enhanced to accelerate customer-led integration development and eliminate traditional blind spots. By introducing native support for Prometheus, the industry's standard for cloud-native and open-source metrics collection, VCF allows organizations to bridge the gap between legacy infrastructure and modern, containerized application ecosystems. This capability empowers IT teams to ingest data from thousands of third-party technologies and proprietary internal APIs into a single, cohesive pane of glass without writing custom code or waiting for vendor-specific integrations. The modernized 5-step workflow in VCF 9.1 fundamentally simplifies data ingestion, mapping, and lifecycle management for Prometheus endpoints. To create a new management pack that leverages this native Prometheus functionality, you begin by navigating to the Solutions catalog under Administration, selecting Integrations, and clicking Create New Design. Within the creation form, after naming the new design, the interface presents a dedicated option to select Prometheus from the Type drop-down menu. Establishing this data source connection is inherently simpler than configuring a traditional HTTP REST API because the endpoints are entirely standardized by Prometheus. This uniformity means you no longer have to define custom headers or complex parameters, as the framework already understands how to look for data. The setup process begins by selecting the target collector and specifying the Prometheus server's IP address, which defaults to port 9090. While Prometheus is frequently run with no TLS, the platform natively accommodates environments utilizing TLS with or without verification. Similarly, if the targeted Prometheus environment requires authentication, this release supports basic authentication where only a standard username and password must be provided. Once this initial configuration is defined, clicking the Connection Test button triggers an initialization process on the back end. The interface then exposes a dedicated Jobs tab specific to Prometheus, which populates with active metric collection targets discovered directly at that endpoint. This behavior provides an immediate visual confirmation that the system can see all underlying targets, such as an internal ClickHouse database or Prometheus monitoring itself, while a concurrent Logs tab remains available to troubleshoot any immediate connection issues. After successfully saving the source configuration, you transition to defining monitored objects by targeting those discovered Prometheus job labels. When naming and creating an object type, the Management Pack Builder features an expanded icon library spanning several new visual categories, alongside explicit support for custom icons managed through the platform's control panel. This leads directly into the metric mapping phase, which allows you to translate open-source metric definitions into native VMware Cloud Foundation structures. The system maps these structures by evaluating the Prometheus metric streams, which adhere to lowercase and underscore naming conventions, alongside their available key-value label pairs. To establish a clear identity within VCF, you select shared metric labels to uniquely identify and name the object, with the standard instance label universally available as a baseline identifier. Fine-tuning this ingestion layer involves applying precise label matching filters directly to metric queries, such as isolating an HTTP request metric to evaluate only actions returning a specific code value. Data transformation is further accelerated as the builder automatically evaluates metric metadata to apply sensible defaults. Counter metrics default to a delta function with rate adjustments available, while gauge metrics expose a function that captures the sum of the latest values by default. This architecture allows for flexible one-to-many mapping, meaning a single Prometheus metric stream can be mapped to multiple distinct VCF metrics by shifting the applied functions and filters under unique display names. Any critical metric stream can also be flagged as a key performance indicator via a quick toggle, ensuring it is automatically promoted to default dashboards. With these internal structures established, the workflow moves to constructing parent-to-child topology rules using the Integrated Expression Builder. By matching specific Prometheus labels against existing VCF object properties, such as a unique identifier, an FQDN, or an IP address, the builder automatically maps the structural dependencies between custom endpoints and the core virtual infrastructure. This expression engine natively supports a combination of static text interleaved with active variables and regular expressions. Before deploying the complete design to a production environment, you transition to the verification step to run a performance collection test. This executes a simulated collection cycle that previews all objects discovered, metrics ingested, and relationships resolved without altering system states. To aid in rapid debugging, the validation screen displays a log viewer showing the last 1,000 lines of execution text. You can adjust the engine's log severity to debug and refresh the screen instantly to inspect deep payload communications without having to rerun the entire collection simulation. Once the collection summaries align with expectations, clicking the Install button compiles the design and instantly registers the management pack for live monitoring. The integration of native Prometheus support into the VCF 9.1 management pack builder represents a massive shift from passive, closed ecosystem infrastructure monitoring to active, open standard observability. By abstracting the complexity of custom API integrations into a clean, 5-step declarative wizard, the platform dramatically lowers the time to value for custom monitoring workflows. More importantly, operational enhancements like in-place upgrades and automatic schema migrations solve a persistent lifecycle pain point, ensuring that custom monitoring scales safely alongside enterprise growth. Ultimately, this release gives organizations the comprehensive, end-to-end operational visibility required to maintain performance, minimize downtime, and maximize infrastructure efficiency across their entire digital estate.